Here's two rules. Rule 1. Given any two events, A and B, the probability of A intersection B equals the probability of A times the probability of B given that A has already occurred. We can solve this for the probability of B given A by just dividing both sides by probability of A, so we'll have probability of A intersection B divided by the probability of A. If two events are independent, then the probability of A intersection B equals the probability of A times the probability of B. What I'd like you to do is compare these two. You see how these parts, the intersections, are the same. Probability of A's are the same. But instead of having probability of B given A, when they're independent, it's just probability of B. What that's telling us is that if we can show that probability of B given A equals the probability of B, then the two events A and B are independent. Now note, you cannot state independence without showing your work. You must justify. Sometimes it goes against what intuition would have you believe. So let's take a look at an example. I forget what number this would be for today's notes, but we'll put it as the next number. We have two dice are rolled. Event A is both numbers are the same. Event B is the sum is 6. Are these events independent? So we're going to need to find probability that the numbers are the same. Numbers the same. Well, how many ways can you get the numbers the same? You can either have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So there are 6 ways to do it. And there are 36 possible. This is similar to one of your homework problems that you had the table that was on page 601. That is 1, 6. The probability that the sum equals 6. Well, we're going to need to list out and figure out how many there are here. How can I get that? I can get 1, 5, or I can get 5, 1. I can have 2, 4, or 4, 2, and I can also have 3, 3. So there are a total of 5 ways to do that, so it's 5 out of 36. Let's take a look at our first one here. Probability of A intersection B. What's common to both the numbers are the same and the sum are 6? Well, it'd only be this one here, 3, 3. So there would be one way to get it, and there are 36 possible. We can take a look now at probability of A. Probability of A, we already are, instead of saying A, I actually should rewrite these and use them for the problem that we're dealing with here. So probability numbers the same and the sum equals 6. And so over here, instead of saying probability A, we can just say probability numbers are the same times, if they're independent, this would have to equal probability that the sum is 6. So multiplication of these two. 1, 6 times 5, 36. And that'll give us 5 over 216. Well, that's definitely not equal to 1 over 36. So there you can see it. So these things are definitely not independent. So are these independent? No, they're not independent. Let me show you another way that we could have shown this. And that would be using that second idea, the probability of B given A equals the probability of B. So in this case, we could really doesn't matter what we're going to name them. I could say also probability of A given B equals the probability of A. And I'm just writing that because it doesn't matter what we call set A and B. We just need to say the probability of one given that the other one has happened. So the probability, how about that the numbers are the same given that the sum is 6. So how many ways can we get the numbers are the same? 1, that was 3, 3. Given that the sum is 6, how many ways did we have that? That was a total of 5. And we know that the probability of the numbers the same, we already worked that out, is 1/6. Since these are not equal, that tells us the events are not independent. And that's it.